Hello again. Welcome. I'm glad you're here because we've got, I don't know, a couple interesting things to talk about. We are going to discuss optimizer nudging. And of course, by optimizer nudging, I mean the process of rewriting queries in order to get the optimizer to do what we want. So this is just a brief video about that. We cannot go into depth about that because then you'd have to pay me and then you wouldn't be watching this for free. So we're gonna just do a little bit about that. If you look down in the video description, right somewhere in here, you'll see all sorts of very helpful links. If you need help nudging the optimizer, well, you can hire me for consulting. If you want to learn how to nudge the optimizer further, you can buy my training. If you just want to support my continuing to provide free help with nudging the optimizer, you can become a channel member and contribute money to the channel. You can also ask me office hours questions, and of course, if you like this content, one of the most helpful things you can do is, of course, like, subscribe and tell a friend, because if you keep it all to yourself, it's very selfish. Pass on Tour. This will be one of the last opportunities for you to purchase a ticket for Pass on Tour Utrecht, October 1st and 2nd. So I forget which day. I forget which day this week I have to stop saying that, but I'll figure it out before I mess anything up. And of course, Past Data Community Summit, Seattle, November 17th to 21st. 2 days of T-SQL pre-cons with Kendra Little. That's me and Kendra Little. Kendra Little and I will be there, teaching you amazing things about T-SQL, and then I'll be home for a bit until, I don't know, someone else decides to pluck me from my domicile and throw me out into the world and expose me to all of you people again. So anyway, let us begin by nudging the optimizer in various and fun and sundry ways, or something like that. So I've got an index created here on the post table on creation date and then score. And we'll talk more about this later, but for now, just stick with me. So we've also got this query, and we're saying, give me the top 1,000 rows where creation date is between these two dates, or betwixt, not exactly between, because between would be less than and equal to 2, right? Between is inclusive in that way, whereas this is exclusive of the stuff. And if we run this query, we'll get what I would call a sort of ugly query plan. All right. We start by seeking into our index, and we get kind of a lot of rows out of there. And then we do a key lookup. And of course, this is sort of a row by row operation, because it is a nested loops join, and then we end up sorting the data over here. So we created an index, but we still have to sort data, which is a bit upsetting. And then at the very end, we top out with our 1,000 rows, and this all takes about 750 milliseconds. Now, the situation can, of course, get worse if we hit upon one of SQL Server's many tipping points. For example, if we say select the top 1,000 and we increment this date by 1 to 2013-03-18. Remember, this was 2013-03-17 up here. SQL Server will neglect to use our non-clustered index entirely, and this will all take about 900 milliseconds after scanning the post table and all that other stuff. So let's say that we're unhappy with this and we want to nudge the optimizer in, again, various and sundry ways. We might decide to rewrite our query like this, where rather than allowing SQL Server to choose between doing a key lookup and a clustered index scan, let's say we do this, right? And we say select the top 1,000 rows from posts where p.id is in yada yada, and we do all that same stuff. Well, we can get much faster performance doing this, because we're kind of taking advantage of some stuff that we know about SQL Server. One, it digs primary keys. Primary keys make things very easy. So if we just say select star from the post table, where the primary key, which is the clustered primary key, which is the ID column, is in these top 1,000 rows, well, SQL Server doesn't really have much to worry about here, because this is a very narrow select list for the top 1,000, right? And even if we were to bump this up to that 18 number that was a tipping point before, well, SQL Server is still keen on doing what we want, right? So this is all a much better arrangement than just writing the query like this. Now, of course, when you are first writing queries, you should arrange those queries logically in a way that makes sense, right? A simple and logical way that attempts to get data the way that you want it. And then if you are unhappy with the performance of those queries at the outset, then you might experiment with different syntax. And this is kind of what this is all about. So adding in the select top 1000 to a subquery, we're still almost doing a key lookup. We're just doing it a little differently, right? Because we still have to look those columns up. We're just writing the lookup in a manual way, right? Because we're saying select star from posts up here, and then we're saying, but just where the ID is in this, and that's what SQL Server does. It gets the 1,000 rows that we care about in here. We still have to sort data, which we'll talk about in a minute. And then you can see that this is where the top isolates those 1,000 rows we care about. And then this is where we go and do the lookup, right? Because we have the nested loops join, and we do a lookup based on the 1,000 rows that we got based on the stuff we cared about up there, and we seeked into the index down there to get the columns we care about just for those 1,000 rows. It's a very, very handy thing. And this comes down to something that I've talked about a bunch of times in other videos, which is sort of separating relational elements from informational elements. Informational elements are things that you want to show to people, and relational elements are things that you need to filter on and order by and other stuff like that. So separating those two in your mind, manually separating those in your mind and then manually writing the query with those separations in mind can do very good things. Of course, one thing that is a little annoying, and I only say a little annoying because, it's just how SQL works, but you couldn't use exists for this. Right, so like a lot of videos where I'm like, hey, exists and not exists, they're pretty great. Problem is, you can't put top in an exists like this, right? So like in the query plan for this query up here, we very clearly have a top operator limiting the rows to 1,000. But down here in this exists query, if we were, scroll down a little too far, blew the whole gag. If we do this, when we just hit Control L, notice we don't have a top here. SQL Server completely throws the top away. Right? SQL Server is like, no, you don't get a top. I'm not limiting rows in the exists. Top is gone. Right? So we couldn't do that here. We could use an outer top with exist. So top 1,000 out here, and then this in here. The thing is, I'm in compat level 160 for this, so I get batch mode on row store. So with batch mode on row store, of course, the query plan looks like this, and I get, I don't know, it takes about 600 milliseconds, and I get an adaptive join, and all these other batchy things happen in here, which, is fine, but it's still not the plan that we're really after, right? Because we want to limit those 1,000 rows before we do anything else, right? So like the adaptive join here is just like, in batch mode, just kind of like, oh, look, we saved the day. If we were using an older compat level, we might see a plan that looks like this with a loop join, right? And we're kind of just back to the original plan we had that took about 700 something milliseconds, 750 milliseconds or whatever. But the 20 millisecond difference here isn't interesting. But it's almost like we're still doing like the manual key lookup, right? It's just not called the key lookup here. We're just joining the two tables together, right? That's what exists is doing. It's just joining essentially, or semi-joining depending on how you look at it. So we're getting the top 1,000 rows from posts and saying p dot star where exists, but like this doesn't, like, I don't know, the other way of writing this that I showed you before with the in was, we could put the top 1,000 in the in clause and just get those 1,000 rows. We ended up way better off. That was like 100 something milliseconds versus 700 something milliseconds. Now, one thing that is worth talking about is you could also consider this to be an index problem, right? So like a very important concept when you're performance tuning queries is aligning queries to indexes, right? So if we look, remember the index that I created up here was on creation date and score. And score, by default, this is going to be ascending order for both of these. all of the queries that we're writing have creation date in ascending order, but score in descending order, right? So that's why we still had to sort data across all of these. If we were to think about this as like, you know, a query index alignment problem, and we took the descending like sort out of score, right? We just said score ascending, then we would end up with a query that's pretty fast naturally on its own, right? Like this takes 2 milliseconds. Well, that's even better, right? That's pretty great. You don't have to worry about sort of getting more in depth with things and rewriting queries in funny ways within and pondering why exist doesn't allow top and all that other stuff. So we might consider this just an index alignment problem. And if we create an index on creation date with score descending, right? So now score is explicitly in descending order in this index, and we go and run that original query, well, guess what? Our original query doesn't need rewriting either. So if you want to think about, you know, if you're in a situation where you can't really change indexes because maybe the tables are too big or you're on standard edition and, you know, the blocking, you know, sometimes you have to think about rewriting queries in a way that takes better advantage of the indexes that you do have. If you are allowed to change indexes, then you might, and you're not allowed to change queries, which is a frequent thing for a lot of the sort of third-party apps that I see people using SQL Server with, then, you know, doing something like this can make queries way better. Of course, if you're allowed to change both, then it's really, you know, chef's choice as to how, what temperature that steak gets cooked at. You can choose to either rewrite the query in a neat way, hopefully with some comments, or you could change, or you could add or change an index that would better conform to the way that you have logically written your query. But these are both forms of optimizer nudging, where we either have our queries conform to the indexes or have our indexes conform to the query. In either case, we end up with better performance. All right, I think that's probably about good here. Thank you for watching. I hope you enjoyed yourselves. I hope you learned something. And do remember to visit the video description down below for all of the helpful links that I can possibly provide for you. All right, cool. Thank you for watching.